Augustin-Louis Cauchy, a pioneer in mathematical rigor and analysis. Augustin-Louis Cauchy, the renowned French mathematician, embarked on his intellectual journey with a background quite distinct from the abstract realms of mathematics. Initially trained as a military engineer, Cauchy's trajectory would soon veer into the profound landscapes of mathematical analysis, calculus, and complex functions. Born on August 21, 1789 in Paris, his early life was marked by the turbulence of the Reign of Terror. Escaping the political upheaval, Cauchy and his family sought refuge in Arcueil, laying the foundation for the life of a mathematician who would significantly shape the landscape of 19th century mathematics. Cauchy's early education unfolded within the confines of a well-educated and aristocratic family. His father, Louis-François Cauchy, held a government position and prioritized his son's education. Augustin-Louis Cauchy's formative years were steeped in a robust emphasis on mathematics and science. His intellectual prowess surfaced early, with the young prodigy mastering much of the mathematical knowledge of his time by his teenage years. In 1805, at the tender age of 16, Cauchy entered the École Centrale du Panthéon, a prestigious institution celebrated for its rigorous curriculum in mathematics and science. His remarkable abilities did not go unnoticed, and he swiftly ascended the academic ranks. This period of formal education laid the bedrock for Cauchy's future contributions to the realm of mathematics. Cauchy's impact on mathematical analysis, a field marred by a lack of rigor in the early 19th century, cannot be overstated. In an era where mathematical results often lacked precision and justification, Cauchy embarked on a mission to elevate the standards of rigor in mathematical reasoning. His seminal work, Cours d'analyse, 1821-1823, was a pivotal contribution where he systematically formulated and developed the foundations of calculus. Introducing a formal and rigorous definition of limits, Cauchy's epsilon-delta definition became a cornerstone of analysis, eliminating the ambiguity that had plagued earlier mathematical arguments. Beyond limits and calculus, Cauchy's exploration extended to the study of continuity. Introducing the concept of a Cauchy sequence, he provided a tool crucial for a rigorous understanding of continuity, allowing mathematicians to define continuity in terms of the behavior of sequences. The Cauchy sequence became fundamental in the development of the completeness of real numbers, contributing to later developments in mathematical analysis. Cauchy's intellectual odyssey also traversed the domain of complex analysis. His work in this realm introduced the concept of a contour integral and delved into the theory of residues. These ideas proved instrumental in unraveling the complexities of complex functions and laid the groundwork for the theory of functions of a complex variable. The Cauchy-Riemann equations, bearing his name in conjunction with the German mathematician Bernhard Riemann, became foundational in the study of complex analysis. Venturing into the practical applications of mathematics, Cauchy made substantial contributions to mathematical physics, particularly in the study of elasticity. His work addressed the mathematical description of materials under stress, laying the groundwork for the study of the mechanics of deformable bodies. Cauchy's theorem in elasticity, formulated in the early 19th century, remains a fundamental result in the field, showcasing his ability to apply mathematical rigor to real-world problems. Cauchy's life was not devoid of challenges, as the political turmoil of the early 19th century in France posed obstacles. An ardent royalist, Cauchy's refusal to align with the new government resulted in his dismissal from various academic positions. Undeterred, he continued to contribute to mathematics and published significant works during this period. In 1830, following the July Revolution in France, Cauchy left his homeland and found refuge in various European cities. Despite the political upheavals, he continued his mathematical pursuits, maintaining correspondence with leading mathematicians of the time. In 1833, he was elected to the French Academy of Sciences, signaling a return to official recognition in his home country. Cauchy's legacy is woven into the fabric of mathematics. His rigorous approach to mathematical analysis set a standard that resonates through the generations. The epsilon-delta definition of limits and the concept of Cauchy sequences are now fundamental tools in the study of analysis. The Cauchy integral theorem and the Cauchy-Riemann equations remain foundational in complex analysis. On May 23, 1857, in Sceaux, France, Augustin-Louis Cauchy departed from the world, leaving behind a legacy that underscores the power of rigorous mathematical thinking.